In late 2025, the inner solar system faces a storm unlike anything in modern records. 7 massive comets, including the interstellar wanderer 3I Atlas, are diving toward the Sun in a single season. Astronomers call it a swarm, one not seen in generations. Too many, too fast, too close. Is this a natural convergence or a cosmic warning we were never meant to ignore? When astronomers first plotted the orbits of the 7 objects now crowding the inner solar system, they thought they knew what to expect. Another comet or two, maybe bright, maybe faint, but still scattered across the years. Ordinary statistics in a restless sky. But within months, those expectations collapsed. Instead of the usual slow trickle of icy wanderers, telescopes revealed something unprecedented. A concentrated surge, 7 major comets inbound, their paths converging on the inner solar system in the span of a single season. Not faint fuzzballs at the edge of detection, substantial bodies, each with its own timetable, each diving toward the Sun in rapid succession. To understand how radical that is, let's step back to cometary history. Most years, astronomers are fortunate to track one comet bright enough for serious study, 2 or 3, if surveys are lucky. Even during so-called comet showers, when several appear over a short period, the numbers rarely exceed 4. That's the baseline. That's the rhythm science has grown comfortable with. But 2025 refuses to follow that rhythm. This swarm isn't just unusual, it's a statistical outlier. Instruments across the globe are watching as objects discovered months or years apart arrive together, threading through Earth's skies and the Sun's influence as though drawn by choreography. Pan-stars, Swan, Lemon, Stereo, periodic visitors, even the alien intruder 3I Atlas itself, all crossing the same celestial stage. And the timing, even stranger. The peak of this comet season overlaps with the Sun's own maximum, when magnetic storms and coronal mass ejections grow fiercest. That means every one of these comets isn't just a spectacle, they're targets. Their delicate atmospheres and streaming tails are about to be tested, torn, even severed by the Sun's volatile breath. Yet the most shocking detail isn't the number or even the alignments. It's what's at stake. 7 major comets, several diving close to the Sun, means multiple chances for something scientists rarely witness live: tail disconnection events. Those sudden, violent moments when the Sun's shifting magnetic field severs a comet's plasma tail clean off, leaving it adrift like a ghost in space. For solar physicists, these events are pure data, live experiments written across millions of kilometers. For planetary scientists, they're warnings of just how unstable a crowded sky can become. Picture a highway designed for a few cars a year. Now imagine a convoy of trucks barreling through at once. That's 2025's comet swarm. Fast, massive, and unpredictable. Even stranger, one of those trucks isn't from our neighborhood at all. Atlas, the interstellar wildcard, isn't bound to the Sun. It's passing through once, then vanishing forever. Yet here it is, caught in the middle of this convergence, as if the universe chose this exact season to test its resilience against solar fire. To researchers, the question became unavoidable. What kind of cosmic mechanics stack 7 icy giants into the same calendar? What force could crowd the sky with this many interlopers at once? And, most unsettling of all, are we just witnessing coincidence, or a pattern we don't yet understand? Because with the swarm of 2025, the deeper astronomers look, the less sense it makes. If astronomers were unsettled by the sheer number of comets arriving together, what they uncovered next threatened to break the foundation of everything statistics had ever claimed about our skies. because under the laws of probability we know this swarm should not exist. Let's break it down. Most years, the inner solar system receives one comet bright enough for detailed study. 2 or 3 if surveys are fortunate. Even in rare periods when several arrive in close succession, the numbers almost never exceed 4. That's the baseline. That's what astronomers call the rhythm of the cosmos. Predictable, manageable, expected. But 2025 refused to obey. Instead of the usual trickle, 7 major comets are now inbound, each one substantial, each one on a collision course with sunlight and solar wind, each one threading through a narrow 6-month window. Their combined presence is not only rare, it's statistically outrageous. The odds of so many sizable comets arriving in such a compressed season drop so low, they're nearly incalculable. Scientists tried to apply the usual explanations. Poisson clustering, the tendency for random events to appear bunched together, offered a tidy framework. But even the most generous models couldn't make the math work. It was like tossing dice across the galaxy and watching them all land on 6, one after another, without pause. And then came the detail that made the swarm even harder to dismiss. One of these objects isn't even from our system at all. 3I Atlas, an interstellar visitor, only the 3rd ever confirmed after Oumuamua in 2017 and Borisov in 2019. Its trajectory is hyperbolic, its chemistry alien, its coma dominated by gases rare in local comets. The chance of such a body appearing in the same season as 6 other major comets. For many astronomers, it's the cosmic equivalent of lightning striking the same spot 7 times in a row. Possible, yes. Believable, barely. That contradiction is what made 2025 so unsettling. It wasn't just rare, it was improbable to the point of absurdity. Too many comets, but too little time. Too much alignment, but no precedent. An interstellar traveler dropped into the middle of it all. It was nothing less than a paradox of probability. One researcher put it this way: it's like scheduling 7 hurricanes to hit the same coastline in one season, except the atmosphere isn't supposed to allow it. So what explains it? The leading natural theory is that survey power has finally reached the threshold to catch swarms that once passed unnoticed. With the Vera Rubin Observatory soon online, maybe we're simply seeing what has always been there. A tidy explanation, but one that raised darker questions. Why now? Why this many? And why include an interstellar body? And then came the deeper concern. If comets really are clustering in ways the models can't explain, what forces are shaping them? Why are their orbits so tightly packed? Why do their alignments coincide with the peak of solar maximum? A few astronomers admitted, quietly, that it almost looked orchestrated, coordinated, deliberate. Is that possible? Officially, no. But then again, wasn't Oumuamua itself accelerating in ways no natural body should? If one visitor could defy orbital mechanics, maybe another could defy statistics. And so the questions grew darker. Was the swarm simply a bizarre coincidence? A statistical fluke across cosmic timescales? Or was it something else? A pattern too complex for us to recognize? A sequence designed to look like chance while hiding another purpose? Whatever the truth, one thing was undeniable. The comet swarm of 2025 isn't just another anomaly. It's a direct challenge to our definition of what random really means in the universe. When the 7-comet swarm first appeared on astronomers' charts, the excitement was immediate. Predictions claimed it might deliver the most dramatic comet season in living memory. Multiple bright objects crossing the skies, perhaps even one rivaling the brilliance of Venus. Headlines called it the cosmic traffic jam of the century, a rare convergence that promised wonder, and for a brief moment, it lived up to the hype. Night after night, observatories tracked the newcomers. Swan raced inward, Lemon brightened rapidly, and 3i Atlas expanded its vast alien coma. For skywatchers, it looked like history in the making, a procession of icy giants lighting up the heavens, a season like no other. But just as quickly as anticipation soared, doubts crept in. The data didn't align. Brightness curves wavered unpredictably. Some comets surged, then stalled. Others dimmed without explanation. Instruments recorded irregularities in gas output, sudden spikes, jagged dips, contradictions that didn't match the standard life cycle of comets. The swarm wasn't behaving like 7 isolated wanderers. It was acting like something coordinated, something caught between 2 states, natural and yet concealed. And then came the revelations about fragmentation. Several of the comets, including Swan and possibly Atlas, showed signs of breaking apart. But this was no ordinary disintegration. Instead of collapsing into rubble, the fragments seemed to separate with eerie precision, slow, deliberate, controlled. And here lies the paradox. Instead of fading, the pieces remained active, continuing to vent gas and light, as if each splinter carried its own hidden energy. Normally, a comet that fractures dies quickly. Its icy heart evaporates, leaving dark debris behind. Yet these fragments refused to vanish. They behaved less like shattered relics and more like parts of a system, each continuing to function. This was no ordinary breakup, so the question spread. Was this the chaotic decay of fragile ice, or the deliberate behavior of something engineered? Adding to the mystery was the silence. Official updates trickled out slowly, often long after the amateur community had flagged the anomalies. Datasets felt incomplete, reports delayed. On astronomy forums, speculation grew. Were agencies hesitating to share details because they sounded too bizarre to be believed? Or was something deliberately withheld? Either way, the narrative had changed. What was supposed to be a spectacular season of comets had shifted into something else entirely. A fortress wrapped in contradictions, a swarm that promised brilliance but delivered enigmas. And astronomers were left staring into the crowded skies, asking themselves, if this swarm is hiding its true nature, then what exactly is waiting behind the veil? For astronomers, the moment of realization was chilling. This wasn't just another busy year for comets. It wasn't random debris slipping into the sun's reach. The data revealed something larger, a coordinated influx. 7 comets, each sizable, each following steep paths into the inner solar system. Statistically improbable, historically unparalleled, and for many researchers, deeply unsettling. Let's break it down. Most comets that we study originate from 2 well-known reservoirs. The Oort cloud, a distant shell of icy bodies extending nearly halfway to the nearest stars, and the Kuiper belt, a flattened disk of small worlds beyond Neptune. From these regions, gravitational nudges occasionally launch an icy body inward, where sunlight transforms it into the glowing spectacle we recognize as a comet. This slow trickle, 1 or 2 bright visitors a year, is the solar system's norm. But the swarm of 2025 refuses to fit that model. 7 major objects, each bright enough to draw attention, are plunging inward together. Some appear to be long-period comets, their orbits stretching millions of years. Others are shorter return visitors, swinging back after decades. And then there is 3i Atlas, the interstellar intruder, moving too fast and on too steep a trajectory ever to be bound to the sun. It is not from here. It will not return. and yet it is arriving in lockstep with the rest. Why? That question has consumed countless late nights in observatories and university halls. One explanation is statistical clustering. Perhaps gravitational interactions simply lined up, causing multiple objects to arrive in the same era. But even those who promote this theory admit the math is ugly. The odds of such a coincidence are vanishingly small. Others argue it may be tied to unseen forces, resonances in the Oort cloud, passing stars that disturbed dormant comets, or even waves of galactic tides tugging on the outer solar system. But speculation runs darker still. Some theorists whisper that this cannot be chance, that the timing, the overlap with solar maximum, the interstellar arrival of Atlas, the ecliptic alignments, feels orchestrated, as though something larger is at work, whether natural or engineered. The thought is unsettling, but not easily dismissed. The chemistry only deepens the puzzle. Swan, one of the brightest, expels torrents of carbon dioxide rather than water vapor. Lemon appears to contain volatile ices more typical of outer reaches than near-sun wanderers. Atlas, by contrast, is almost alien, its coma dominated by gases rarely seen in local comets, its tailless veil stretching wider than planets. Each comet seems to carry not just a different signature, but a different story about where it was born. Put together, they represent a patchwork of cosmic origins stitched into a single season. Imagine it. Fragments of icy bodies from across the galaxy, some native, some foreign, all crowding the sun's stage at once. A convergence of histories, compositions, and chemistries spanning billions of years. And here they are, clustered in front of us, daring humanity to interpret their message. That is the safe reading, that we are simply witnessing nature's diversity, compressed by chance into a single dramatic year. But then there's the timing. 3 interstellar visitors in less than a decade. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. Before that, none confirmed in centuries of watching. Either our technology suddenly became sharp enough to catch what was always there, or something truly has changed in the traffic of our cosmic neighborhood. If the latter is true, the question becomes urgent. Why now? Are we merely passengers in a solar system that happens to sit along a galactic highway? Or are these objects drawn by something specific, our sun, our planet, or perhaps the unfolding cycles of solar activity itself? No one knows. And that ignorance gnaws. Because here is the unavoidable truth. The comet swarm of 2025 is not just a spectacle. It is a test. A chance to measure chemistry, orbits, and solar interactions at a scale never before seen. A chance to uncover whether these arrivals are mere coincidence or a signal written in ice and fire. Whatever the explanation, one thing is undeniable. The swarm has already rewritten expectations. Too many comets, too close together, too improbable to ignore. And so the question echoes through observatories worldwide. Are we witnessing a fluke of nature or the first chapter of something far stranger? By now, the official explanation paints 2025's comet season as extreme, but still natural. 7 icy bodies, each from different corners of the solar system and beyond, all arriving within months. A statistical outlier, yes. A rare coincidence, perhaps. That is the safe story. Clean, logical, comforting. But the swarm doesn't feel like a natural story. It feels staged. Swan flaring with alien chemistry. Lemon fragmenting yet refusing to die. Atlas, an interstellar giant cloaked in a veil wider than planets, struck by solar storms but still intact. And the timing. Every arrival compressed into the peak of solar maximum reads more like choreography than chance. For many astronomers and skywatchers, those alignments leave the door open, and through that door rush theories once dismissed as impossible. One idea whispers that the comets are not just wanderers, but carriers, that their outgassing is less about chemistry and more about dispersal. Microscopic payloads scattered into the solar wind like spores. Nature perfected this on Earth. Seeds, pollen, spores drifting on currents to colonize new ground. Could advanced civilizations scale that principle to the stars, sending knowledge, sensors, or life itself hidden within fragile shells of ice? Then there's the sequence. Why Oumuamua in 2017, Borisov in 2019, and now Swan, Lemon Stereo, Pan-STARRS, and Atlas all converging in 2025. NASA and ESA admit our detection capabilities are improving, but the sudden cluster feels deliberate. Some insist it's only statistics catching up. Others wonder if waves of objects are truly crossing our system, timed with a precision we cannot yet decode. Speculation does not stop there. Some theorists describe Atlas's shroud as camouflage, a massive plasma veil venting gas yet masking the nucleus, scattering sunlight and confusing sensors at the very moment scrutiny peaks. If natural, it's chemistry. If artificial, it's deception, designed to hide its core from observation. And if that sounds absurd, recall that even Harvard's Avi Loeb argued openly that Oumuamua might have been a probe propelled by radiation pressure. If such speculation can be debated seriously, is it truly unthinkable to apply the same logic to Atlas or to a swarm of 7? Push the thought further. What if at least one of these bodies isn't a comet at all, but the degraded remains of something technological? A machine so ancient its structure has eroded, leaving only trails of gas and dust to mimic nature. To our telescopes, it looks like an icy wanderer. In reality, it could be the husk of a construct drifting silently between stars. Wild, yes. But the swarm forces us to consider it. We can dismiss extremes, reassure ourselves with natural explanations, and maybe those answers will hold. But the contradictions linger. There is a paradox at the heart of 2025. On one hand, science offers models, galactic tides, statistical clustering, rare chemistry. On the other, the story feels too dramatic, too deliberate. Until these comets round the sun and vanish, we cannot know for certain. And maybe that is the most haunting truth. Because if even one of these visitors conceals something engineered, then humanity has already stared at technology or a message without realizing it. Was this swarm a bizarre coincidence or the first wave of something larger? The truth is, we don't know. And that unknown may be bigger than the comets themselves. If you're fascinated by these mysteries as much as we are, hit subscribe and turn on the bell so you don't miss the next chapter, because what comes next will make this swarm look like only the beginning, and you'll want to see it.